So before we continue on in chapter 19, I want to start by just kind of reminding you of what we're doing, of what the point is, because I think one of the tricky parts of chapter 19 is that people tend to forget the point, what we're actually talking about. Chapter 19 is all about lipids. And we started the chapter by just defining a lipid. It's a biological molecule, it's nonpolar, and we talked about two classes of lipids initially, the fatty acids and the steroids or hormones, which the steroids will be the last thing that we talk about in chapter 19. And so we looked at the structure of a fatty acid, and then we talked about how the fatty acid is the building block for three other types of lipids. First, we talked about waxes, and then we talked about the fats and oils, the triacylglycerols. And now what we're going to talk about are phospholipids. So phospholipids are lipids that are composed of or made up of fatty acids. They are hydrolyzable, and they are the components of cell walls. So let's add just some facts about phospholipids. Structurally, they're very similar to a triacylglycerol. So we'll make a note of that. They have a very similar structure. Their purpose inside of our body is to make up the main component of our cell membranes, our cell walls. There are two different types of phospholipids. One type of phospholipid is called a glycerophospholipid. Glycerophospholipid. And the other type is called a sphingomyelin. So two types of phospholipids, and they have slightly different structures. Of the glycerophospholipids, there are two types of those as well. And actually, before we talk about those two types, I got to give you another name for glycerophospholipid. Phosphoacylglycerol. So kind of like when we were doing the fats and oil section, fats and oils can be known as triacylglycerols or triacylglycerides, and you could see either one of those names depending on what textbook you're using. Glycerophospholipids and phosphoacylglycerols, these are also two names that refer to the same thing depending on which book you might be looking at. So there's two different types of phospholipids, and we are going to start by looking at the glycerophospholipids or the phosphoacylglycerol. So that will be our number one. Glycerophospholipid, also known as phosphoacylglycerol. And let's just call these, because those are such long words, let's call these that doesn't make sense. GPL for glycerophospholipid. We're going to call it GPL for glycerophospholipid. So the general structure of a glycerophospholipid really closely resembles the structure of a triacylglycerol. It has the glycerol backbone. Oh, I want to move I'm really second guessing myself right now. I want to move my drawing more over to the middle of the page. So I've got the glycerol backbone, the exact same as we have for the fats and the oils. And the glycerol backbone has 3 things on it, just like we saw for the fats and the oils, the triacylglycerols. And the first 2 things that are attached are fatty acids. So this is very familiar. Fatty acid on top, and then we have a fatty acid in the middle. And the fatty acid connects to the glycerol molecule in the exact same way as the triacylglycerol does. So that much of it is exactly the same. And just like with our triacylglycerols, these fatty acids can be anything. They can be any fatty acid. So we don't have any kind of rules about what they can and cannot be. In the third spot, we do not have a third fatty acid. Instead, we have a phosphate group and an amino group. And when we represent glycerophospholipids, instead of drawing the phosphate and the amino group over to the left-hand side like we normally do, we actually are going to draw that third group pointing in the other direction. And I will explain why. Now this is going to be kind of tricky because I have to leave myself enough room to write backwards. So the first thing that's attached is the phosphate. And I'm going to draw a structure of what phosphate looks like. And then attached to the phosphate is another group which is called an amino, because it's part of it is an amine, and alcohol. Those are 2 words, amino alcohol, because it has an amine group and an alcohol group. And so the reason that we draw this a little bit differently than the way that we would draw a triacylglycerol is because of the polarity of the molecule. So the fatty acid portion of the molecule is a nonpolar portion of the molecule. Nonpolar. So this means, because it's nonpolar, this means that it is repelled from water, so it's not attracted to water. And this is going to be really important when we start thinking about this in the context of cell membrane. And then the other portion of the molecule, the amino alcohol and the phosphate, this portion of the molecule is polar, which means that it is attracted to water. For the triacylglycerols, the whole entire molecule is nonpolar. So with the triacylglycerol, it's normal for us to draw all of it together in a clump like that because we're looking at just one big giant nonpolar blob. But with the glycerophospholipids, we want to draw it showing the nonpolar portion of the molecule and the polar portion of the molecule being kind of pointed in opposite directions. Not only is the polar part of the molecule attracted to water and the nonpolar part of the molecule repelled from water, the nonpolar part of the molecule is also repelled by the polar part of the molecule. So within this molecule, it's got some issues within itself in terms of being repelled by the rest of itself. So as I said, or I think maybe I didn't say this yet, there are actually 2 different types of glycerophospholipids based on the structure of the amino alcohol on the glycerol backbone chain. So there's 2 types. 2 types of glycerophospholipids. And those 2 types are lecithin, lecithin, lecithin. And the structure of lecithin we're going to draw in its entirety. So we've got our glycerol backbone. We have 2 hydrogens on the top carbon. We have 1 hydrogen on the middle carbon. We're not going to worry about the bottom carbon yet. We've got an oxygen on the top 2 carbons. Remember, this is just our normal fatty acid chain or fatty acid tail. And there's some kind of R group out here, some long carbon chain. That's what defines it as a fatty acid. For our bottom carbon, this one has 2 hydrogens as well. But remember, we want to turn this group around and draw it going off to the left. So where we would normally draw our hydrogen number 2 off to the left like that, this time we're going to draw it off to the right so that we have room to draw the phosphate and the amino alcohol out here. So first we have the phosphate group, and the phosphate group is an oxygen bonded to a phosphorus that's bonded to 2 more oxygens. So it's a phosphorus surrounded by 4 total oxygen. One of those oxygens is a phosphorus oxygen double bond, and traditionally it's in the position that I've shown right there. And one of the oxygens has a negative charge. And so this much of the molecule is the phosphate group. And then attached to that is what we call the amino alcohol. And in lecithin, that is going to be a CH2 followed by a CH2 followed by a nitrogen. And the nitrogen is going to have 3 CH3s attached. So here is its structure. I would never ask people to memorize this structure, not even in a regular situation, regular on-ground class, but I would want you to recognize it when you see it. So if somebody gave you a structure of a phosphoacylglycerol and asked, is this lecithin, yes or no, I would want you to be able to match it up with that structure. When we make a cartoon drawing of lecithin, a lot of times you'll see the lecithin molecule represented as, oh, actually, let me put a mark on this. This is our amino alcohol. So when we're making a cartoon representation of lecithin, sometimes you could see it represented as a rectangle that has a couple of squiggly lines coming off of it. Sometimes you might see it as a circle that has 2 squiggly lines coming off of it. And when you see that type of notation, the squiggly lines, which I'm going to highlight in green, are representing the fatty acid tails on the molecule. And then the rectangle or circle, we call this the head of the molecule, that is representing the phosphate and the amino alcohol group. And we say a lot of times it's labeled that this is the polar part of the molecule. Sometimes it's called a polar head. And this is the nonpolar part of the molecule. Sometimes it is called the nonpolar tails of the molecule. So that's number 1, the first type of lecithin, or of a glycerophospholipid. The second type of glycerophospholipid is called cephalin. And cephalin has a very similar structure to lecithin. So we're going to move through this kind of fast. We still have the 3-carbon glycerol backbone. We've got hydrogens, 2 on the top, 1 in the middle. We've got those 2 fatty acid tails on carbon on the top and also the carbon in the middle. And our carbon down on the bottom, it has its 2 hydrogens as well. It has a phosphate group, oxygen, phosphorus, oxygen with 2 more oxygens, 1 with a double bond, 1 with a negative charge, and then the amino alcohol group, which is a CH2, CH2, NH, H. So very similar. The only way that these 2 structures are different is with regards to what is attached to the nitrogens on the amino alcohol group. That's the only spot where they're different. So just like with lecithin and with all of these, the fatty acid tails can be anything. We can represent the molecule in terms of its polarity, with the phosphate amino alcohol group being the same polar head and the fatty acids being the same nonpolar tail. So those are the 2 different types of glycerophospholipids. And then also, let's scroll back up. So we just talked about the 2 glycerophospholipids. Now we need to talk about the sphingomyelins. So this is going to be number 2, sphingomyelin. And I think this is usually kind of confusing for students to organize in their notes, because we have phospholipids and there's 2 types of phospholipids, glycerophospholipids and sphingomyelins, and then there's 2 types of glycerophospholipids. So it's just, I think it's the 2 types twice that gets people kind of confused. Sphingomyelins are also cell membranes, but they are specifically cell membranes that surround nerve cells. A lot of times you might hear these referred to as being components of what we call the myelin sheath, which is like the insulation or protection around a nerve cell. Sphingomyelins have a different structure from the triacylglycerols or glycerophospholipids. Mostly, like the most notable difference in their structure is that they don't have a glycerol backbone. They do still have a backbone, but it is kind of upside down L-shaped, like this. And this background or backbone is a molecule called sphingosine. Sphingosine. And the sphingosine, the way that it is shaped, it occupies one of the, what would be a tail, a fatty acid tail, on another type of molecule, another type of lipid. The sphingosine backbone in itself takes up one of those spots, which means that there's only room for 2 tails on the sphingosine molecule. So we can't fit 3 things in. And none of them are fatty acids. The tail in the middle, the spot in the middle, is going to be an amide. And the amide structure is really similar to a fatty acid structure. So they're pretty similar. Just as a refresher, the fatty acid structure is oxygen, carbon, oxygen, like this, whereas an amide has just got a nitrogen in place of one of the oxygens. So for our last position, just like the glycerophospholipids, this is going to be on the other side of the molecule. So it's going to be going in this direction. And this over here is going to be a phosphate, which is followed then by an amino alcohol. The phosphate group is the same for all of these different phospholipids. So we will make a note here that this phosphate group is the same as for these guys up here, our glycerophospholipids, GPLs. And then the amino alcohol also is going to be the same. Let's scroll back up. With our glycerophospholipids, we had 2 different amino alcohols to form 2 different molecules, lecithin and cephalin. So again, we have the same 2 amino alcohols as in the glycerophospholipids, but with the sphingomyelins, we don't give them different names based on their amino alcohol. With the glycerophospholipid, we will call it a lecithin or a cephalin based on its amino alcohol, but that's not the case with sphingomyelins. No matter what, we just call it a sphingomyelin. And just like with the glycerophospholipids, these portions of the molecule are polar, so they move off onto this side right here. And this portion of the molecule is nonpolar, so we get, again, the polar head, non-polar tail cartoon representation for the sphingomyelins.